Everyone, this is the activity series experiment 9 lecture. Okay, what is an activity series? This is a table listing elements in order of decreasing reactivity, in which the more active metals, which are at the top, will lose electrons more easily, and they will then push out the less reactive ones in a single displacement reaction. So to picture that, we are using a set of fictitious elements, Y and O and W. So in the first reaction that you see, a reaction does occur in which you can see that Y has replaced O in this single displacement reaction. So when that happens, it means that Y is more reactive than O because it had, let's say, enough power to push out O from the reaction, in which now Y was by itself, but now O is by itself in the product side of the reaction. But on the other hand, the opposite could be true when you have a set in which there's no reaction occurring. So you can see that Y plus W chloride, and there's no reaction. This means that Y was not able to push out W in this single displacement reaction. So that means that Y is more reactive than W. So in conclusion, we can see that W is more reactive than Y, but Y is more reactive than O. So everything that I've kind of quickly ran over so far can help you answer your pre-lab exercise. After this, we're going to go over everything that you need to understand how to answer your report sheet. But also, I've only went over a couple examples of what an activity series means and how to create a reaction. If you want to know more, watch Professor Skipper's video in which she goes over an activity series of the elements that you are familiar with. Just to make a note here, before I get started, is that you're going to have to watch Alyssa's lab video, which of course you should do anyway, but I want you guys to know to pay very close attention to every reaction because you're going to need to know whether or not it occurred in order to even start completing your report sheet. So for part 1, we're going to go over the reaction between gibbsum and wernium nitrate. So I made that into a little bit of a single displacement reaction on your right side. And we can see, as you will see in Alyssa's video, that no reaction occurred here. So that means that gibbsum could not kick out wernium in this reaction. So wernium is more reactive than gibbsum. And I want you guys to understand that as you go through the lab, for every reaction that you go to, please write out which fictitious element, in this case, is more reactive than the other. Alrighty, so part 2, as is on your report sheet, you're testing the reactivity of iridium here, or AH, with all of the other made-up elements. So your whole purpose of this lab, if it wasn't clear before, is that you're going to go through all of these reactions. You're going to figure out the reactivity of each of these fictitious elements, which are actually real elements, but they're giving another name for this lab. And then you're going to create your own activity series. Pretty much the exact same thing you did in the preliminary exercise with all the letters, but these you're looking at reactions and then whether or not they occur, to then finish the product side, figure out which is more reactive. Alrighty, so pay attention in this case for part 2 to Alyssa's video to determine if they react, like I said. And I'm just going to tell you on this part that there should only be one that does not react. Alrighty, so a couple things I want you all to remember is that These are the 3 steps you must follow for every set of reactions that are listed out for you. So, on number 1, look at the charges on page 121 to complete the product side. So this is pretty much just like you would do with your nomenclature, in which you're trying to make sure everything is neutral before balancing the equation. So I'm going to skip a little bit to part 3 just to give you an example here. And let's see. So, or actually, no, I'll go back to part 2. I'm sorry, I don't want to confuse you. So on the first part of part 2, the first equation that you see is iridium reacting with Lavoisium chloride. And I'm going to tell you now that this reaction does occur. So that would mean that iridium is going to go over there and it's going to kick out Lavoisium. So then Lavoisium is by itself on the product side of the equation. So we're going to have Lavoisium plus iridium chloride. Now if you go to page 121, if you go to page 121, you will see that iridium has a charge of +2, and we know that chloride has a charge of -1. So to make sure that that is neutral, you can use the crisscross method, in which you get Lavoisium plus iridium chloride, and there's 2 chloride elements attached. After you do that, you're going to make sure that the equation is balanced on both sides. And you guys should have a lot of practice with that from the last lab. And then the third thing is just another reminder, is that write down which fictitious elements are more or less reactive than iridium. And then you're going to have to write that down on the second part of part 2. Alrighty, so part 3 and 4. They're pretty simple enough, is that you're going to do the exact same thing for part 3 as you did with iridium, but now it's Luwium. So you're going to do the same thing. Remember to look at its charge to complete the equation before balancing it, like I said before. For this one, I can tell you that there's only one reaction occurring. You're going to have to figure out which one that is for yourself by watching Alyssa's video. And then part 4. So as you can see on part 4, there's not a written out equation for you here, but you're going to look at your observations. So Lavoisium is going to react with hydrochloric acid. If there is a reaction and that follows through, you'll probably see bubbles, and that would mean that Lavoisium is more reactive than hydrogen in this case, because it was able to kick it out. And that would be the last things that you would need to do. So once you've gathered all your information of all the reactions, you can move on to the very last part of the lab, which is, of course, creating the activity series. So like I said, once again, throughout the entire experiment, you should have already been creating like your own mini-series in which you determined which element is more or less reactive for every reaction. Now when you get to your chart, you can see that there's a whole list. You're going to, I think it would be probably best if you, on a separate piece of paper, wrote out every one of the reactions, or what you found for each of the reactions. Like, was Lavoisium more reactive than hydrogen, or was iridium more reactive than Lavoisium, etc. Write those all out from what you found for every reaction so that you can see them all in one place before you start trying to create this activity series. So pretty much all you're doing is finding the correct order. The most reactive is on top and the least reactive is at the bottom. And then all you need to do is explain why. You can just tell me pretty much of one of the reactions that you saw and what happened, and then why you think that that element is more reactive than another one, or less reactive than another one. So that is all I have for you guys. I hope that made sense. If not, make sure that you also watch Professor Skipper's video. I know it's a lot better when you have two people explaining it to you than just one. So I hope you guys are doing well, and I hope this lab goes smoothly for you. And that's all I have.